So this week we are beginning Unit 2, which is now moving into the purely microeconomic topics. So the first chapter we will be covering is Chapter 5, which is on elasticity. Now elasticity may be something that was touched on in your high school econ course. However, in the context of this chapter, we're probably going to be going into some more advanced topics that you've never covered before. Now let me start off the lecture by giving you a scenario. Let's say that I currently own a restaurant. And suppose I notice that the ordering process is not very streamlined from the servers to the line cooks. Therefore, I want to install a new computer system that is going to streamline the ordering process. So of course we know that this is going to be a capital good. So it's going to be a capital cost to the firm in order to acquire this new computer system and have it installed. Now I decide that in order to cover the cost of that new computer system, I'm simply going to raise the price of the restaurant meals that I serve. So let's say that I raise the price and immediately I see that revenues fall. So I raise the price of the restaurant meal and the amount of money coming in immediately begins to fall. What that means is that I did not understand the elasticity of demand for the product that I sell. When we are referring to the elasticity of demand for a product, all we are talking about is the attempt to measure how consumers change their purchases in response to a price change. So think of yourself and all the different things that you purchase on, a monthly basis. I'm sure that you identify that for some goods and services, as the price changes, you may alter the amount that you buy by quite a bit. However, for other goods and services, when the price changes, you do not alter the amount that you buy. Therefore, you have what's called different elasticities of demand. So again, in my example for the restaurant, I thought that I could just raise the price of the restaurant meal and consumers were not going to respond to that. In other words, I thought I could raise the price, still sell the same number of meals, and just increase my revenue flow to cover the cost of the computer system. However, I raised the price and my revenues fell, which means consumers were more responsive to that price change. In other words, they altered the amount of meals that they were purchasing from my restaurant. So of course, when we ask the question, well, who is this information important for? It would certainly be information that is important to the businesses, right? Businesses want to understand what the elasticity of demand for their products are, because that's going to tell them whether or not they can increase or decrease the price of their products and experience a substantial increase or decrease in the amount that they are able to sell. Now, the formal definition of price elasticity of demand, if we're putting it in mathematical terms, is going to be the percent change in the quantity demanded of a good divided by the percent change in the price of a good. So here we see that formula right here on the lecture slide. So if you already had the percent changes, then you can just plug those numbers into that formula and it would give you the numeric value for the elasticity of demand for a product. So going back to that very first example that I gave you, when I said, let's say that I raise the price of my restaurant meals and my revenues fall down, let's say that we did have the percent changes. In other words, let's say that the quantity of meals sold at the restaurant fell by 3% and I only increased the price of the meals by 1%. So because I have those percent changes, I can plug those numbers into my formula, which is right down here on this slide. In other words, I already stated the formula is the percent change in the quantity demanded divided by the percent change in the price. So the percent change in quantity demanded was a negative 3%. In other words, the quantity demanded fell by 3% and the percent percent change in the price was an increase in 1%. So a negative 3% divided by a positive 1%, we would come up with the numeric value of negative 3. Now you'll notice that I state thus the price elasticity of demand for a meal is 3. In other words, I'm looking at it in its absolute value. I have dropped that negative sign, and there's a good reason for that. Remember that when we covered chapter 3, we talked about the law of demand. And the law of demand basically told us that if the price of a good increased, the quantity demanded was going to decrease, and vice versa. If the price of a good decreased, the quantity demanded was going to increase, right? So we see that there's this inverse relationship between price and quantity. Now our formula for elasticity of demand is percent change in quantity demanded divided by percent change in price. Therefore, we're always going to be dividing a positive by a negative. Therefore, elasticity of demand is always going to be negative. But that negative sign doesn't really mean anything. All it means is that the law of demand holds, right? That the price of the good is increasing, the quantity demanded is decreasing, and vice versa. So we basically just disregard the negative sign, which is why I generally state the elasticity of demand in absolute value. So again, going back to this previous example, I wouldn't state that the elasticity of demand is negative 3, I would just state that it is 3 because, the negative sign is irrelevant. We already know the law of demand. We know that there's an inverse relationship between price and quantity. Now, when we talk about some different elasticities in this chapter, the negative sign actually means something, so we wouldn't drop it. But when we're talking about elasticity of demand, again, it doesn't mean anything, therefore we just look at it in terms of its absolute value. So now we need to know, what the heck does that mean? What does a value of 3 mean? So the value that we come up with tells us how elastic the demand for the good is. And there's basically 3 different regions of elasticity. There's what we call elastic demand, unit elastic demand, or inelastic demand for a good or service. So if we come up with a value that is greater than 1, just like we did in the previous scenario where we said the elasticity of demand for restaurant meals was 3, that would mean that you're dealing with elastic demand because you're coming up with a number that is greater than 1. So when you have elastic demand for a good or service, what you're basically saying is that consumers are more responsive to price changes. So think of it in percentage terms. If there's a 1% increase in the price of a good, consumers will decrease the quantity that they demand by more than 1%. That's how we're able to come up with a value that's greater than 1. So consumers are responsive to price changes. So for example, let's say that I purchase something like, eggs for my family for breakfast, and the price of eggs increases by 20%. If I had elastic demand, then what that would mean is I would decrease the quantity demanded by more than 20%. So I would be able to come up with a value greater than 1. In other words, because I can substitute the purchase of another breakfast item, then that would explain why I would have more elastic demand. So the price goes up, I can buy something else instead. So products that generally have a lot of substitutes available are going to be products that have more elastic demand. You can also have what's called inelastic demand, so that would be down here. If you have inelastic demand for a good or service, what that means is that you are not as responsive to a price change, and the value that you come up with numerically is going to have a value of less than 1. So greater than 0 but less than 1. So in other words, if demand has inelastic demand, that's when we say consumers are not as responsive to a price change. So a good example of that would be something like gasoline, right? In other words, let's say, for example, and this would be a true example of what's happened in the last week, the price of gasoline increases by some percentage. So let's say the price of gasoline increased by 5%. But I only decreased my consumption of gasoline by 1%. So again, I'm going to come up with a number that is less than 1, which means my demand for gasoline is inelastic. When there's a 1% increase in the price of this good, the quantity I demand is going to decrease by less than 1%. So goods that have more inelastic demand are going to be goods that don't have a lot of substitute products available to them. So in other words, it's not that I want to continue to purchase so much gasoline, it's just that there's nothing else I can put in my car to make it go. Therefore, I have more inelastic demand. I'm not that responsive to a price change. All right, the third type of elasticity of demand that we can have, it's what's called unit elastic demand, and that is where the price change in the product, or the percent change in the price of the product, is equivalent to the percent change in the quantity demanded, which is why you would come up with a value of 1. So in other words, if there was a 1% increase in the price of a good, it led to a 1% decrease in the quantity demanded of a good. So if demand for a good is unit elastic, then that means you're coming up with the number 1. So just to recap, a value greater than 1 is elastic demand, less than 1 is inelastic demand, and a value of 1 is unit elastic demand. So let's just plug these numbers into our formula to make sure we know how to do these calculations in the case that we were given the specific percent change values to begin with. So for number 1, it says the quantity of DVDs that are rented falls by 4% when the price of DVD rentals rises by 2%. So we know that we're going to take the percent change in the quantity demanded, so that's going to be a decrease of 4%. Divided by the percent change in the price, which is going to be a positive 2%. 4% divided by 2%, in terms of its absolute value, we come up with the value of 2. Therefore, we know the demand for DVDs is elastic because we came up with a value that is greater than 1. And of course that makes sense because DVDs are not the only form of entertainment that we have. There's a lot of other things that we could do to entertain ourselves. So because there's a high number of substitute goods, it makes sense that DVD rentals would have more elastic demand. Number 2 says when the price of gasoline rises by 5%, the quantity demanded of gasoline falls by 1%. So we have a decrease in 1% of quantity demanded divided by an increase of 5% for the price of the good. So a negative 1% divided by a positive 5%, taking into the absolute value of the good, we would come up with a 0.2. Or again, if you're looking at it in fraction form, it would be 1/5. But either way, no matter which one you're looking at, we know that that is less than 1. Therefore, the demand for gasoline is inelastic. And of course, I already stated previously that the reason for that would be because there's not a large number of substitute goods that we could purchase instead. And then number 3 is just saying when the price of bus passes rises by 2%, the quantity of bus passes demanded falls by 2%. So again, you have a negative 2% divided by a positive 2%. That means we came up with the value of 1. So the demand for bus passes is unit elastic. So now that we know how to numerically calculate the values of elasticity, let's look at the actual demand curves. What do demand curves look like when they have these varying levels of elasticity? We also have a couple of extreme examples of elasticity that we want to look at. We have something that's called perfectly elastic demand, and that demand curve is going to look like a horizontal line. And we also have what's called perfectly inelastic demand, where it's going to be an actual vertical line. So neither one of these look like the demand curves that we discussed in chapter 3. So they don't abide by the law of demand. And so we're going to talk about when that situation would occur. But most goods and services are going to have demand curves that look very much like the demand curves we discussed in chapter 3. In other words, the law of demand is going to hold. It's going to have a downward slope. But what's going to vary is the value of the slope depending on the elasticity of demand for the good or service. So let's actually look at the graphs, because then it starts to make a little bit more sense as to what this means. So looking at graph A on this slide, that is an example of perfectly elastic demand for a good or service. And again, this is going to occur when the quantity demanded has nothing to do with the price of the good. Notice, for example, that it doesn't matter, excuse me, I was looking at the wrong slide. So again, starting over. Graph A is an example of what we call a perfectly elastic demand curve. And this is a demand curve that's going to reflect demand where consumers are so responsive to a price change that even a price increase of a penny, demand is going to go to zero. So again, let's say that we have this demand curve right here. Let's say that's at a price of $1. And notice that at $1, the quantity demanded does not change. It stays the same no matter what. However, if we raise the price from here up to here, notice that demand goes to zero. We are now along our axis and there is no demand. So there's only demand at that one initial price point. So this is going to occur in markets that are generally commodity markets, where there's very, very large quantities of the goods or services being sold, so that not one producer has an impact on the price of a good. So let's say we're talking about something like corn production. So there's a global supply, demand for corn, and there's tons and tons of farmers all over the world that grow corn. And that creates a global prevailing price for the corn. So let's say the price of the corn is $1 a bushel. Well, if one farmer decides that he wants to charge $1.10 per bushel, you can see why the demand for his product would go all the way down to zero, because why would anybody pay him $1.10 when there's 1,000 other farmers selling it for only $1? So again, this is only going to happen in what we call perfectly competitive markets, which we'll discuss when we get into Unit 3. The second extreme example of elasticity would be a product where there's perfectly inelastic demand. So that's the opposite. If there's perfectly inelastic demand for a good, then what that means is that the price can go up and up and up. So that's what we see here, right? The price can be here, the price can go up to here, the price can go up to here. However, we don't alter the amount that we purchase. It stays exactly the same. So the best example I can think of for this would be if you depend on a pharmaceutical drug for your survival. So let's say that you are a diabetic and you need insulin. If you don't take your insulin, you'll die. Therefore, you don't care if it's $10, $20, $100, you're going to buy that insulin as long as your income allows you to, because if you don't, you will die. So again, very, very particular products that fall into perfectly inelastic demand category. So those again are two extreme examples of elasticity, perfectly elastic versus perfectly inelastic. Most goods and services have demand that's going to look like a downward sloping demand curve, like we discussed in chapter 3. So that's what we see right here. Demand curve 1, demand curve 2, and demand curve 3, although they all have different slopes, they are all downward sloping. But what we can identify by looking at the slope is whether or not the demand for a good is relatively elastic versus inelastic compared to each other. So I'm going to show you how and why that occurs. So let's say, for example, that I have two different demand curves. I have demand curve A, which is a fairly steep curve, and I have demand curve B, which is not as steep. And let's say that both goods experience the same price increase. let's say that initially the price is here and the price goes up to here. So again, we can go and see where we intersect our demand curves based on these two different price levels. So for the product for demand curve B, notice that initially we wanted this quantity over here. However, when the price increased to P2, that caused us to decrease the quantity wanted all the way over here. So we decreased the quantity we demanded by by a half, it looks like. Whereas for the product along demand curve A, notice that initially when the price level was here, we demanded this amount, and when the price went up to here, we only decreased our demand to this amount. So look at how small we decreased the quantity we demanded for the same exact price increase. So we went from P1 to P2, we altered our consumption of product B by a whole lot, but for the same price increase along demand curve A, we decreased our consumption by a very small amount, which illustrates different elasticities of demand. One product, we altered the amount we purchased a lot, which was product B. The other product, we altered the amount that we purchased by a very little amount, which was product A. So again, just looking at the slope tells us, again, relatively how elastic or inelastic the demand for a good is. If I said, comparing the demand for good A to demand for good B, which one has more elastic demand, you would say good B, because consumers were more responsive to the price increase for good B. So again, the steeper the slope, the more more inelastic the demand. And the flatter the slope, or I should say the less steep, the more elastic the demand becomes. So again, just by looking at the slope, you can see that the demand for A is much more inelastic than the demand for B. Now, for some products, so again, if I said which one of these would represent the demand for gasoline and which one would represent the demand for potato chips, you would say that the demand curve A is most likely to represent demand for gasoline, whereas demand curve B is more likely to represent the demand for potato chips, because we know gasoline is a product that doesn't have a lot of substitutes, whereas the demand for potato chips does. Now, we can also segment a particular market. In other words, what if I said which one of these would represent demand for gas and which one would represent the demand for gas specifically at a Shell, right? Well, we know demand for gas is going to be more inelastic than Shell gasoline, because once you start to segment the market, then you have substitutes. In other words, yes, I need gas, but do I need Shell gasoline? No, I can get Shell, I can get Arco, I can get Texaco. In other words, I don't have to get Shell gasoline. So if I said which one of these demand curves is more likely to represent Shell gasoline, then of course you would choose the one that is more elastic. So the Shell gasoline would be demand curve B, whereas demand for gas itself would be demand curve A. So we have inelastic demand for gas, but we have elastic demand for the different brands of gasoline. You could use this same argument for food. In other words, which one would represent the demand for food, which one would represent the demand for, again, potato chips. Well, demand for food is generally inelastic, right? You need food to survive. So we would say demand curve A represents food. However, if we're just talking about a specific food like potato chips, that would be demand curve B, because we don't have to eat potato chips, we can eat other types of food. So again, not only does the elasticity of demand vary from product to product, but it also depends on, how you define the market, whether you're just talking about the overall good or whether you're segmenting the market into individual products or brands. Now, in addition to examining the slope of a demand curve to determine how elastic versus inelastic the demand for a good is, we also note that the elasticity of demand actually varies along a straight line demand curve. So as you move down your demand curve for a good, your demand moves from elastic to unit elastic to inelastic. That is because of the formula that we use to calculate the elasticity of demand. Remember, the formula is not the change in quantity demanded divided by the change in the price. It's the percent change in the quantity demanded divided by the percent change in the price. So because it's percent changes, those values are going to vary along the straight line demand curve. So in other words, look at going from a price of $1 to $2. Going from $1 to $2, what is the percent change in that value? The percent change would be 100%, right? In other words, it increased by 100%. We went from 1 to 2, which was a 100% increase. However, what if we have that same incremental change? We now go from $2 to $3. So again, just like here, we're only increasing the price by $1. Here we went from $1 to $2. Here we're going from $2 to $3. So the same incremental increase in price. However, now what's the percent change, right? Now the percent change is 50%. Because we went from $2 to $3. In other words, we only increased the value by 50%. So even though we had the same incremental increases in price, the percent changes in price were different, which would cause this denominator to be different if we were talking about different, changing the price from 1 to 2 versus 2 to 3. And then of course, we're going to have the same thing happening in terms of the percent change in the quantity demanded for the numerator. Notice that going from a change from 180 to 200 is a different percent change from going from 160 to 180, even though the incremental values are the same. So because the percent changes are going to vary along the straight line demand curve, that means that we're going to have different values going up and down that demand curve. So again, when we're talking about elasticity of demand, demand always goes from elastic to unit elastic to inelastic as we move down the demand curve, meaning that at the top of the demand curve, the values are greater than 1. The middle of the demand curve, the value is 1. And at the bottom portion of the demand curve, you come up with values that are less than 1. And to just hammer this concept home a little bit more, in other words, when we're looking at percent changes in product, it ensures we're comparing apples to apples. So just, this is a more extreme example, but it makes you understand how our alterations in what we purchase are more influenced by percent changes in the prices opposed to just changes in prices. So let's say both college tuition and Big Macs experience a $1 increase in their price, right? So again, we have the same incremental increase in price. So whether we're buying college tuition or whether we're buying a Big Mac, we are having to spend $1 more out of our pocket. So let's say the initial price of our college tuition was $1,000. So now instead of paying $1,000, we're going to have to pay $1,001. Therefore, the percent change in price was only 1/100th of a percent change. However, a Big Mac was initially priced at $2 and so increased by $1. So now the price is $3. That percent change in price was 50%. Which one do you think is more likely to have an impact on whether or not you purchase that good? Now, of course, we would have to plug it into the formula for percent change in quantity demanded divided by percent change in price. But just looking at just the percent change in price alone gives you an idea of how it's the percent changes in price that cause us to alter our purchases opposed to just a change in price. Because both of these examples we see, we're going to have to pay $1 more no matter what. However, a $1 increase in the price of a college tuition is probably not going to have an impact on our demand opposed to a $1 increase in the price of a Big Mac probably will.